Awesome. Wow. Okay, great. So my name is Marcel. I'm going to talk to you about drawing an owl. Now, on Twitter, I said I'd have wine on stage, but I couldn't find any in the morning. So I just have this tiny beer that I found in the speaker's room. Go me, what an achievement. Today, we're going to be talking about how to draw an owl and how it relates to static typing in JavaScript. That's right. I use a cute owl to sucker you in to talk about static types. And we're going to cover topics like what was promised with static types, and why does it feel like it hasn't really delivered? Why do we still have frustrations that it promised it would solve? And is it something we can do better? Now, on the way over here from the airport, I was in a car with a very senior Twitter engineer who, in all seriousness, asked me, blank-faced, JavaScript is types? So I was like, OK, we'll have to scale back a bit and a little bit of history, because I remember this is a Java and JavaScript conference. So, a little bit of background on the one that it is, JavaScript. This resolution's a lot bigger, so everything's smaller. You'll have to forgive me. So it was designed in 10 days by this guy called Brendan Eich, and originally for the Netscape platform. It was called LiveScript, but Java was still gaining popularity at the time, so they thought, let's call it JavaScript and ride that wave. It was inspired by Smalltalk and Scheme, which are Lisp languages, the ones with all the brackets at the end, and always a bit of fun to program in. It was actually just designed for amateurs, people who aren't really professional programmers. And it kind of stayed that way until Gmail. So back in the day, there were 3 big email providers. There was Hotmail, Gmail, and Yahoo Mail. And Yahoo Mail looked like this. And what Yahoo Mail and Hotmail had in common is they were very, very slow, because every single button click was a new re-render. So you click on reply, it goes to the server, it gives you back all the new HTML. You hit, forward, it does the same thing, a whole new web page. And then Gmail came along and said, that's very, very slow and very frustrating. How about we just use something called Ajax to get just the data we need, and then the application runs on the client, and it's a much better experience, and this blew everyone's mind. Around the same time, this bad boy landed, jQuery, which helped standardize a programming interface for all these different browsers, because they all had different ways of traversing the DOM, they had different little quirks, and by programming through jQuery, you can make an application that hits every browser fairly consistently, so now you actually have a platform. Now, we're all aware the DOM is actually a terrible platform. It's designed to host images and text, and it wasn't really ever meant to be a foundation. But it does have some good things in it, and this is why it proliferates today. It's incredibly accessible. All you need is a browser. You don't need an iPhone. You don't need to install an exe. It's just a website. You can push updates instantly. Do you know how much I would kill to be able to push updates instantly to old desktop apps that I've lost contact with? There's no build pipeline. Not in the olden days. You just wrote some JavaScript in a notepad and it ran. And it was a very minimal startup costs. Notepad.exe is all you needed. And over time, as the momentum with Java grew, Google capitalized on this and launched Chrome. So JavaScript applications were getting big and slow. So they made V8 and launched Chrome. Now JavaScript is fast again. We can make even more complex JavaScript. And then they went, hey, we've made this thing to make JavaScript fast. How about we make a server out of it? And so Node was born. And now you have back-end and front-end JavaScript. And it's gone on with things like Electron, where you can make desktop apps in JavaScript. So all these kids who've been doing JavaScript for many, many years can now touch all these different parts of the ecosystem. And it's been a tremendous success for the language. As you can see by a Stack Overflow poll, at least, JavaScript is miles ahead of JavaScript, and then you have somewhere in the middle there's Java, and then there's another form of JavaScript just below it, penning it in. There was a cool ARM slide here that never made it in. Dang. One thing to note is that processors today now optimize for JavaScript. The new spec for ARM, which is the processor that probably lives in your phone, has special instruction set optimized for JavaScript. You now have JavaScript running metal, because everyone has just accepted that JavaScript will be around forever, and JavaScript will be a key component in our technology for quite a while. But of course, managing these massive applications using a language that was really just meant to be a hobbyist language is very difficult. Modern JS has huge complexity. We want a lot out of our applications, and it's a lot more critical. real-life dependent systems now run JavaScript. Even NASA's new spacesuit runs Node, and I don't want to kill someone because undefined is not a function. It's long-lived. Like, it used to be like, oh, we make a web page, we forget about it, but now you're working on the same code base for maybe 5, 10 years. So how do you think about refactoring and improving incrementally over time? And it runs everywhere. It's not just in the browser. You have to think about how do we make sure this code runs well on things like servers and desktop applications. So we've created this menagerie of tools to try and pen in the complexity and make sure that we don't go mad trying to keep the genie in a bottle. So we've got stuff like types, like here represented by TypeScript, but it could be Flow or Elm, to sort of give us a little bit of certainty. We have things like ESLint to make sure that we're not writing terrible code up front. We have things like Babel because at some point we realized that we needed new language features now, and it was too slow to wait for them to be released, and they'll never be supported in IE 11. So we created a pseudo JavaScript that compiles to other JavaScript to save us the time. And we have tools like Prettier to make sure that we don't squabble about code. And these kind of things are put together in a way that helps us create complex applications of a language that wasn't really designed for it. This is a slide. And here we have the comment about in the spec that the people have just decided that JavaScript here is for a long time. We're just going to put it straight into our processes. OK, cool. That was the unrehearsed set of slides made yesterday in the car. Now we go back to types. Types promise a lot. They promise like code confidence, they promise faster refactoring, they promise fewer test cases because you no longer have to test if what happens if null goes in this function because null should never go in a function. And said there should be improved readability because you've got all the function signatures and tooling support. Your IDE will be able to help you out so much more because it knows so much more about your code. So, of course, types are wonderful. Are they? If they're wonderful, why aren't they everywhere? I give a lot of talks in a lot of weird places because I like sleeping on the street. So generally when I go to conferences, I ask people, how many people here use static types in the JavaScript? So as a show of hands, who uses static types in the JavaScript? Cool, we're like 8%. And I found basically outside of the bubble cities where, nerds congregate, like London, San Francisco, and New York, the takeover was much less. And you could be saying, well, isn't that TypeJS new? But TypeJS isn't new. If you look at the 4 big players in the field, you had Flow that was introduced in 2014. TS has been around since 2012. Elm was 2012. And New Kid in the Block Reason is 2016. And it's only been very recently that a clear front runner in this field has emerged. There are trade-offs between all these different options. And it was uncertain if one would ever actually take a lead. So we have lots of people who don't bother using static types, an argument about which static types to use, and even people who use static types rarely embrace them fully. They'll use them for the easy things, and then go, oh, the hard things are super hard. To the point that even industry thought leaders tell people that they're just like, oh, this sounds difficult. I'm just not going to bother. Like, I'm just not going to unit test this code. It seems difficult. And I replied, this is going in my slide deck tar as an example of terrible practice. And he liked it because he thought I was being positive. So, what an interesting state we're in. How did we get here? It seems like a non-optimal configuration. Well, so I think what happened is my pet theory is that we have all these problems we need to solve, and they're only going to get worse. People want more from their web applications, and JavaScript's going to be more prolific, and people are going to live for a longer time, and it's going to be used for more and more critical things. And I think some well-meaning Haskellite or other static typer flew by and said, hey, use types. That's how we deal with critical applications in other fields. And you go, OK, yeah, why not? Let's use types. So the problem is summarized possibly in this great internet meme on how to draw now. You have the first step, which is very understandable and approachable to everyone, and it's intuitive. You feel very comfortable with it. But then getting to step 2, where you actually create the thing that makes it more of an owl, is completely beyond the capability and there's no instruction. So how does this map onto these static types in JavaScript? Cool. How to use types in JS. Well, maybe you go to the TypeScript documentation and you're like, okay, I can get started on this. So we've got like add A and B is plus A and B, and I can put like the string 2 and the number 2, and it'll accept that, and it'll print the string of 22 because JavaScript. And you're like, okay, no, I know how types work. I'm going to add A and B and send them to both numbers, and it has to give a number back. Now when I say add 2 in a string 2, it's going to tell me, oh, you can't do that. Yeah, I feel like a static type god. This is that computer science degree in action. So you feel very confident. First circles, very easy to draw. You think you've got the basics, you think you've mastered it. But then you use types on a real project. And it didn't tell you. So you've got challenges like writing types. You have to spend a lot of that time doing that up front. And not everything just takes 2 numbers and returns a number. So you've got this issue of, what about this thing that's like several types, or dynamic types, or things that are spread in from other ways, or have dependencies on other types. You have to maintain the types, because now you've made them, you've got to always update them and make sure they're correct. You've got to deal with third-party types. Can you really trust them? Do you check them? You go and, definitely typed and have to update all the definitions for other people. And you have duplicate types. So if you're running Node, if you're running Node on, if you're on Node and a web client and they're both TypeScript, it's super easy because you can share the types. But what if your backend's Java? Well, now you have a type definitions in TypeScript for the client stuff, and you have a different kind of type definition for the Java stuff. Now you've got to make sure priority. That sounds like a real pain. Then we've got editor tooling. The editor something gets slow, and it's not very helpful. The build process is complex because you're balancing several kinds of linting and build pipelines, and it's kind of trying to go for a Webpack loader, and it always breaks, and somehow it's different on CI because they're on a different opportunity cost here as well. So we could be doing more unit tests or anything else, but we're choosing to do types, and we're choosing not to do other things. There's also long-term risk. Like, if we really invest in the static type language and it's a compiled JavaScript one, what if it falls out of favor? What if it's like CoffeeScript, and in 3 years' time we have to unfuck ourselves? It's going to be a terrible job. And lastly, we have to consider people. People are tricky. And people are the most important part of software. When you tell people to write code in a completely new way that is unfamiliar to them, that is frustrating because you have to do all the effort up front, like test-driven development, you're telling people to spend a lot of effort writing stuff that they won't see the benefit of, and you can't really prove that they will. You never do the same project, one with and without tests, to see which one was better in the long run. And getting people to change habits requires social effort and social energy. So there's a lot of empathy you need to keep for your team, because we made you feel more junior and less effective by just following your blind proposals for this whole new type language. But there's all these benefits. You've read about them, you believe them, there's people on Twitter who tell you it's true. But you just don't know how to get there. So this is our 2-step process for using types in JS. Add takes 2 numbers and returns a number. Great. And then we just elevate the rest of the fucking JS ecosystem and practice it to new unfathomable heights. Easy. So you have some frustrations. And I think if we look at these systematically, we can bring them into 2 categories. We have frustrations with the tooling and frustrations with the language. Language and tooling. Tooling, editor integration. Sometimes integration is really bad. Flow was terrible for this. It would break in weird ways. It wouldn't have a great UI for you to see what's going on. You can interdependency errors where you can upgrade your type system, but then you might break them other packages. You have bad errors where it's just unhelpful, like there's an error in this file, line 1, character. Not super helpful. And there's setup. So you got all this build process and complexity you're adding to your system to try and get these types in. And languages often also have failures. So you have lots of annotations. You have to put the types in by yourself, even though it's only called in one place by some other function, some other file. You're like, you should be able to infer that. Why can't you? Some of them are very permissive. So they have things like, hey, you can be straight or not undefined. I don't care. But that just means that you don't really get the benefits of strict type checking because it could still be a bunch of stuff that blows up at runtime. Sometimes there's difficulty with external packages. So Elm, which is a very beautiful language, has a very difficult time using external packages. You want to use Moment, you have to write a very complicated binding scheme. And features. A lot of type systems just put types on JavaScript, but that really misses the point of and operators on types. Many modern languages use types for things like pattern matching, which means you can express yourself more concisely and actually use the types more innately rather than just trying to bolt it on the side. So, what have you learned? Typing JS is hard. Should we just give up? Of course not. That's not why I'm here. So, let's look at all these problems about where we've come from and where we are, and things are better. Like, none of these type systems are perfect, but we can continue to iterate to a positive outcome. And actually, if we look at like the big four in this group, they all try and solve different problems. They have different trade-offs. They all take different parts of these issues and attempt to get rid of them. Flow has a really good inference engine, but terrible tooling. So it's one of the best type systems. No one wants to use it because the upfront cost is just terrible. And you go to your team like, you could use Flow. Flow is not working on my computer. Oh, it works on my computer. We have Elm, which is great. It actually lets you use types. It's a wonderful language, but it doesn't hit many targets. You can only use the web, and JavaScript runs everywhere, and it's very hard to do external packages. And then there's our boy TypeScript, who is in the lead, I think, more or less, because it has been the one that solved tooling. And this is because Microsoft gives you VS Code, and also Microsoft integration between the platforms, which means you get a really, really slick experience when you start. Except maybe speed. But the language itself has a lot to be desired. But we're getting there. We're incrementing to somewhat positive. So, where next? So TS will continue to progress. It'll have speed updates. 3.5 launched the other day, and it has supposed speed updates. I haven't tested it, so I can't vouch for them. It'll continue to get small language features, and we're getting more tooling, even more tooling on the other tooling around TypeScript. So things like Apollo CodeGen, which lets you look at a GraphQL schema and generate the TypeScript types out of it. So now when your endpoint updates, you automatically get a side effect validation between both the server and the client. That's really cool, but you have to run it statically, and it's progress. But TypeScript does have some drawbacks that we've kind of milled around on. So the build process is complex. You've got to use TSC and probably bundle it in with Babel anyway. It's not type sound, and it never aims to be type sound. It's stated that that's never something it wants to do, and that means there's a limitation on the certain kinds of certainty it can give you. Type soundness is basically if a type system goes, hey, I'm a string, you can be 100% sure it's a string if it's a type sound system. If it says, hey, I'm a string, and it's a non-type sound system, it could still be something else. So for the eagle-eyed audience members in the room, you may have noticed that we've not talked about this small red boy in the corner very much. And as a next increment, how about a new approach? Typing JS is really hard. Would getting a natively typed language to output JavaScript be easier? Well, let's do a thought experiment. If we were to pick a language, we probably want one with a great compiler and a lot of history and a really good type system. So how about OCaml? Yeah, it's 20 years old, and it's a systems language, but it's great. It's got a camel. Camels are cute. TS doesn't have any animals. So, it's got a sick compiler. It's very, very, very quick. It's very easily extensible because there's a multi-step compiler. So we can like put our stuff around it. It's got the Hindley-Miller type system, which is a structural type system, different from like the class instance style you find in classical OOP. And it's been used in Critical Role for years. So you go, okay, that's great. I can write OCaml, but how do we turn it into JavaScript? Well, fear not. A company that sells very, very expensive keyboards called Bloomberg has made something called BuckleScript, which is what they use to do most of their internal services and their financial products. So you write OCaml, it goes through this thing called BuckleScript, and out comes JavaScript. So this is the compile tree. We write some OCaml, We do get it into BuggerScript and it turns into JavaScript as an intermediate layer. So at this point, you might think that I'm losing my mind, but bear with me. So we talked about how hard it is to get people to change their ways, and we want to make it an easy transition of incremental change so people always feel comfortable. One of the problems here is that OCaml looks like this, which, you know, when people argue about very minor syntax changes and then refuse to work on things, this is probably a departure too far. Look, 2 semicolons. Woo! All right. But is there something we can draw inspiration from? Is there another language that was actually really cool but no one used until they gave it a modern syntax and made people feel comfortable? Oh, yeah, it's our boy Erlang. Erlang is a great language for distributed systems that's been around forever. And people use it a little bit, like WhatsApp was famous for using it and scaling their systems. But the real push to popularity came when they gave it a Ruby-esque syntax and called it Elixir, which is the droplet on the side. So, OK, let's rebrand. Let's call it Reason. It's great. And now we have an alternative syntax to write OCaml, because the compiler is very extensible. So we can write OCaml or ReasonML, which looks like JavaScript, and out comes BuggerScript and JavaScript. And this is what it looks like. So we can see that this left looks very, very similar to JavaScript, except the compiler has already picked out all of the types for you. It knows it takes an int and returns an int, and the result on let is an int. You don't have to tell it, it's smart enough. And this is the generated output JavaScript. And you see it's pretty human readable, and it's done some cool stuff, like, for example, it's pre-computed the result, because it knows that's always going to be the same value. So yeah, it's a very efficient compiler. So there's going to be, you know, probably some very understandable doubt. You have questions like, Marcel, you idiot, are you seriously suggesting I write applications in an alternative syntax for a 20-year-old systems language that is compiled to JavaScript by a fancy keyboard company? Yeah. Who would imagine such a thing, let alone build it? Oh, yeah. Well, the guy who made React, actually. He's called John Walker, and he is a mysterious man. He did a couple of talks when he launched React, and he's like reclused into the darkness. But this has been worked on for quite a while by John Walker and the extended team. So let's see if ReasonML can tackle some of these issues that we were talking about before in the tooling and the language space. So Facebook Messenger is written in Reason. It has over 40,000 files, an incremental rebuild, less than 0.1 seconds. It also has a really good compiler that has all the things like Prettier and libraries already inbuilt. In fact, Prettier was ripped from Reason's reformat, which is why it's written in OCaml, which means you don't need any of these tools. You just need ReasonML. You also get really nice errors, so nothing too cryptic. Here we can see the old adage of trying to put a string into the where it was in a nice and comforting way. Almost to Elm level. Elm is still nicer in its error messages, trying to get there. So OK, tooling-wise, it's great. But what about language features? Well, we have all inference, which is great. So we define a type of owl. And then we make an object of an owl, and we never say what object it is, but because it has the same structural similarities, it knows it's an owl. And it even knows that we use species here, and we only define it in one type, so this must take an owl and return a string. I never typed any of this. The compiler can just infer. That's good. Less typing. There's also one issue that many compiled JavaScript alternatives have, which is trying to get external packages into your code. And the foreign function interface in Reason is very, very simple and still gives you type security. So here we use math.random from the JavaScript space and try and add it to a string, and it shouts at us. But the actual notation for it is quite easy. So you retain type safety, but it's not hell like Elm. And for actual language features, we jokingly call it ES 2030, because you have all this good shit that's been, wished on for a while. So we got things like variants. You no longer have to stringly type things. These are ways of defining different things being more expressive in your code. You have things like pattern matching, and you have things like typing, all built in because it comes from the wondrous OCaml compiler. And there's even an escape hatch, so you're not buckled to it too hard. You can always go back to JavaScript if you need to, because often with a lot of these tool change, there's always like some small thing that you really need and can't do, and someone's like thinking about it in the GitHub issues, maybe solve in the next 6 months, and your boss is screaming at you because you've got real business needs to fulfill, and say, why don't you just use JavaScript? So, tooling and language. Pretty good coverage. Now, of course, there are trade-offs. There are some things to consider, like the JSON handling is still kind of clunky. Async, there's a few ways to do it, and people are quibbling about it. And like pioneering is hard. There is very little documentation. I mean, there is documentation, but compared to JavaScript documentation, like it's not comparable. And so you say, should you try it? Well, we're going to have a quick. Oh, there you go. Excellent. I put in my peer and I forgot about it. So should you try it? Slowly, maybe. Maybe put it in points where you find TS frustration, like trying to handle spread props or doing things with dynamic fetching, where the type system here would help you more. You can mix it in pretty easily. But don't go all in and then, be annoyed and put pressure on your teammates. So what did we learn? Types in JS are hard. Types in JS are still important because we have all these problems we still need to solve. And that effective change requires incremental progress and empathy for the people around you. But you're already here in this conference, which means that you're much more likely to want to try new things. So be the change you want to see in the world. Thank you. Early. I should have dawdled more.
Any questions?
Yes, you in the front row. Yes, I'm using it in production. It's quite funny because that's what everyone asks. It's the one go-to question, do you use it in production? Because that's the one certainty that people are going, am I an idiot for believing in this? The last recent conf the theme was on the road to production, where people just showcase things they do use in production because of this, to give people like some of the rough edges that we need to polish out and bring attention to places that do use in production and have a network of people to help if you do get stuck.
You mentioned Apollo code gen for TypeScript, but I remember Reason has something amazing for Apollo as well in terms of types. Can you give a highlight?
Sorry?
Can you give a highlight about Apollo tooling for Reason?
So Apollo doesn't, so that's interesting. You don't need tooling because there's something called the PPX, which extends and already understands graphical schemas, and it can convert it to reasonable types. So you have this inbuilt system where you can write graphical statements, and it types them for you against a live schema, and also corrects your code and where you use it. So you don't need Apollo CodeGen. Apollo CodeGen is great for things like Flow and TypeScript, but Reason has it built in, and it does it as you type at each compile, rather than just like you have to like remember to run the Apollo CodeGen every time you commit with TypeScript or Flow. But it's a very cool piece of software, and I wouldn't undermine it.
Hello, not so much of a question, but just pointing something out. So you mentioned that one of the reasons that TypeScript was so successful was how it was working so well with tooling, namely VS Code, which is true. Also, one extra reason I would say is that it's forcefully in Angular 2, so that if you ever work with that framework, you get to experiment, and then like me, you end up really enjoying it.
Yes, I think that's true. There's definitely, you will use this aspect that, for example, Flow never had. No one ever pushed Flow on someone. Whereas Angular community, some other front-end communities, doesn't mean there's always like the seed of expertise that has been grown. I think you're right.
Yeah. Do you think there's, I'm curious, for your presentation or Reason ML, do you think it will ever be bundled somewhere?
That's a great question. I'll think about that. I'll get back to you.
Okay, thanks. That's all we have time for.
Excellent, I survived.